Hello friends, today I will discuss about the realization of NOT gate using transistor, PNP transistor. Let us first see the NOT gate. This is the logic symbol of NOT gate. Say this input is A, output is Y, then Y is equal to A bar, that is A complement. That means if input is 0, output will be 1. If input is 1, output will be 0. Let us now try to understand the working of NOT gate using transistor. Let us use NPN transistor. In NPN transistor, collector is N-type semiconductor, base is P-type semiconductor, and emitter is N-type semiconductor. So the arrow at the emitter should be from P to N side. Let us use a resistance here, RC, and another resistance at base R. Whenever we are biasing any transistor, we must always remember that collectors should be always reverse biased. Now, collector is N-type semiconductor. For N-type to be reverse biased, it must be connected to positive voltage, say positive VCC. And emitter must be always forward biased, so it should be grounded. And say this is input A, and let us take the output at the collector circuit 1. Now, let us define what is high, that is logical 1 state, what is low, that is logical 0 state. In this circuit, the maximum voltage we have applied is plus VCC, and minimum voltage is ground, that is the 0 volt. So let us define 1, that is high, as plus VCC, and ground as low, that is 0 logical state. Now let us give the input to the circuit. Let us first give A equal to 0. Input is 0. That means base of the transistor is connected to the ground, and emitter is also grounded. So there is no potential difference between base and emitter. So the base emitter junction of the transistor will be reverse biased. If it is reverse biased, there is no base current to the transistor. If there is no base current, transistor is actually cut off. If transistor is cut off, there is no current flow through the transistor. That means there is no current flow through the collector. That means IC is 0. If IC is 0, that means the voltage drop across the resistance RC is IC into RC is 0 according to Ohm's law. Okay. So whatever supply voltage at the collector, that is not dropped across the RC. So at output, that is at this point, whatever supply voltage we have fed will be appearing. So output will be plus VCC. That means it is logical 1. So whenever we apply 0 at the input, we will get 1 at the output. Let us now input 1, that is logical high. So logical high means plus VCC. Now base is connected to plus VCC and emitter is grounded. So this base emitter junction is now forward biased. If base emitter junction is forward biased, now there will be a base current from base to the emitter, IB. So whenever there is base current in the transistor, that transistor is actually saturated. Whenever transistor saturates, the transistor conduct. So now there will be current flow through the transistor IC. Now IC is not equal to 0. Now if there is current flow, that means there is a current through the resistance RC IC. Now according to Ohm's law, the voltage drop across this resistance RC is IC into RC. This is almost equal to plus VCC. That means whatever supply voltage we have fed, whole voltage is dropped across RC. So no voltage appears at the output. Now Y will be equal to ground. So ground means it is logical 0. Hence, whenever we apply 1 in the input, we will get 0 at the output. So in this way, the NOT gate can be realized using NPN transistor.